All right, welcome back. Hononegah Honors, Algebra 2. The beginning here is going to be pretty basic, and then we're going to upgrade a little bit as we go along here. But we're going to start off by adding and subtracting polynomials. Basically, what you want to do when you are adding and subtracting like terms, you're looking for the same letter, same exponent. If you have the same letter and the same exponents, you're allowed to add them together. So 2x cubed and 1x cubed makes 3x cubed. Notice when I add and subtract, just like when you're adding and subtracting just a single x, you don't change the exponent, you merely add or subtract the coefficients. So 1x squared and 7x squared make 8x squared. Now I like to cross these off as I go just to kind of remind myself of which ones I've done and which one I haven't. So negative 3x doesn't have something that's alike, and the 4 and the negative 2 does. Now notice that I put this in descending order, meaning highest degree to lowest degree, just like you did when you did standard form in section 4.1. So the next one, again, I'm looking for the highest exponent, so I see a negative 4y cubed that doesn't have anything that's alike. I see a plus 2y squared and a 1y squared, which makes 3y squared. Negative 1y and negative 6y. And then positive 2 and positive 9. So again, I always go in descending order, and I always cross them off as I go. You don't have to do that. Ultimately, you just have to add like terms, but you do have to put it in descending order when you're done. All right, subtraction. Now, there's two ways of doing this, and I don't care which way you do this. Ultimately, if I see a subtraction sign, I need to make sure that I subtract all of those. Now, if you're somebody that usually forgets one along the way, then you should probably go ahead and rewrite the question. So instead of doing a subtraction, I'm going to add and then distribute the negative. So negative 3x cubed, negative 5x squared, positive x, and minus 8. Otherwise, you just got to remember to subtract every time. So I have a 5x cubed minus a 3x cubed. I get 2x cubed. So those two. Negative 4x squared minus 5x squared makes negative 9x squared. Negative 3x minusing a negative, which is why it's plus, makes a negative 2x. And then 1 minus 8 is a negative 7. So again, this one I'm not going to necessarily do the same thing I did up there. So 7z squared minus 5z squared makes 2z squared. So again, I just have to remember to subtract every time. So a negative 4z minus a negative z makes a negative 3z. And then a negative, so there's 0, nothing to add, minus 3. So again, all depends on how, if you make sure that you're going to subtract every time. Otherwise, make sure you rewrite the question. Multiplying. Now, when you multiply a binomial times a trinomial, okay, basically what I always tell everybody is to go ahead and multiply the one with 2 terms to the number with 3. So x gets multiplied to each one of these, kind of like distributing. So 2x cubed, a minus 3x squared, and a plus 5x. And then do the same thing with the negative 2 to each one of those. So I'm going to get negative 4x squared minus 6x minus 10, and then add all the like ones together. So again, 2x cubed, doesn't have anything that's alike, minus 7x squared. Notice I don't change the actual letter. I'm just adding and subtracting the like stuff. Negative x, and a minus 10. So multiplying. Next one. Again, I'm going to multiply. And this is one of my favorite questions of the year. So again, I'm going to move this down just a little bit. Ready? So I'm going to take the y times each one. So I'm going to get 2y cubed minus 4y squared plus 3y. Then I'm going to take the 8 times each one. So positive 8. 16y squared minus 32y plus 24. And I'm going to add all the like stuff together. So 2y cubed, like terms, plus 12y squared, that's these two, minus 29y, these two, and then a plus 24. Now, you're going to wonder, why in the world is this one of his favorite questions? Because this makes math art. It's a bird with a beak eating a worm. Next one. Now, anytime you have multiple, kind of like when you have 2 times 3 times 5, you're going to take 2 times 3 and then multiply it times 5. So again, anytime you have more than 2 parentheses, you basically multiply 2 of them together and then multiply it times a third. So here we go. I'm going to take the first 2 and FOIL. First, outer, inner, last. And so x times x, negative x, positive 2x, minus 2, and I add like terms. Again, math art. Now I'm going to take that answer times x minus 3. X times each, which gets me x cubed plus x squared minus 2x. I'm going to take negative 3 times each. Negative 3x squared minus 3x plus 6. Now, once I have multiplied the first term times each and the second term times each, now it's just a matter of go ahead and adding the like terms together. So x cubed minus 2x squared, that 1x squared minus 3x squared, negative 5x, negative 3x, and negative 2x, plus 6. Questions? All right. Now, there are patterns to this, and it's worth memorizing in some cases, but really I don't feel like it is. If you're taking the sum and difference, so like an x plus 3 times an x minus 3, there's a pattern to it. Or if you're squaring a binomial, there's a pattern to it. Or if you're cubing. Now, when you start getting down to cubing, it's a little bit worth maybe understanding the pattern, but it's like a 1, 3, 3, 1 situation, and we'll talk about that in just a second. But let's do a couple of ones, and I'm going to show it to you. Most of you are just going to FOIL this, which is fine. 4x squared minus 14x plus 14x minus 49. And oh, look, because these are differences, they're going to end up canceling the middle. So if you ever have the same binomial, but one's plus and one's minus, it will always end up being the square of the first minus the square of the second. Every time. And so this next one, again, most of you, and this one is one of the most missed questions on the quiz, is they forget to actually FOIL this out. You don't just square individual parts, you have to FOIL. So 16y squared plus 12y, another plus 12y, and a plus 9. And so again, there is a pattern to this that most of you will not memorize, but it squares the first, multiply and double the middle, plus square the second. So you square the first one, multiply and double, square the last one. And again, I wouldn't necessarily recommend memorizing, but it can be done. Last one, and again, a situation that memorizing this would probably be actually harder than just doing the question where you're taking AB plus 2 times AB plus 2 plus 8 times AB plus 2. Now this is starting to get to the level of memorizing might be a little bit faster, but here we go. Multiply, so I get A squared plus, or A squared B squared, sorry, A squared B squared, plus 2ab, another plus 2ab, plus 4. So again, that pattern where you square the first, multiply and double, and square the second. Now, ab being distributed to each one of these. So you end up getting a cubed b cubed plus 4a squared b squared plus 4ab. And then 2 times each one, so 2a squared b squared plus 8ab plus 8. And then I'm going to add all the like terms together. So a cubed b cubed plus 6a squared b squared. Notice I'm not changing the letter. 12ab plus 8. And so the pattern to this, and I realize it said it's a little bit quirky as far as the pattern goes, but you're going to cube the first, and then you're going to multiply the two together and times it by 3. Okay? Or actually, you're going to square the first and times it, and 10 times it by 3. Then you're going to square the second, times it by, and multiply, and then you're going to cube the last one. So again, that pattern is pretty hard to memorize, and so I don't recommend memorizing it. I just recommend you actually doing it. Now, with that being said, there is a pattern to all of these. It's called Pascal's triangle. It's a binomial expansion. So anytime I want to multiply a binomial, any binomial, raised to any power, then I actually can do this without going x plus 3 times x plus 3 times x plus 3 times x plus 3 and so on. Okay, there is a special triangle called Pascal's triangle. It was made by a French mathematician named Pascal. With that being said, this is what Pascal's triangle is. Now, I want to show something, and I don't like the way they did it, but I'm going to show Pascal's triangle here underneath this, and I want to see if you guys can see this. Ready? X plus 1 to the 0 power is just 1. Okay? X plus 1 to the first power is 1x plus 1. X plus 1 to the second power is 1x squared plus 2x plus 1. X plus 1 to the third power is 1x cubed plus 3x squared plus 3x plus 1. X plus 1 to the fourth power is 1x to the fourth plus 4x to the third plus 6x squared plus 4x plus 1. Now, what do you notice about each one of these? I'm going to have to use a different color. To the 0 power, to the first power, to the second power, to the third power, to the fourth power. So in Pascal's triangle, the first level of Pascal's triangle is x to the 0. X to the first, to the second, to the third. And how you know that is just look at the second number. That would tell you where it goes. So I can do any one of these, and I'm going to show you how to do it on the next page. X minus 3 to the fourth. And so I will need the fourth row of Pascal's triangle. And here's how this works. Take the numbers. Those are the coefficients in front and write them down. So 1, a 4, a plus 6, plus 4, and a plus 1. And then take the first term in the parenthesis and do it in descending order, meaning x to the fourth, x to the third, x to the second, x to the first, and x to the 0. And then take the second term in Pascal's triangle, or the second term in the parenthesis, and do it in ascending order. So negative 3 to the 0, negative 3 to the first, negative 3 to the second, negative 3 to the third, and negative 3 to the fourth. Answer time. The answer would be each one of these. So what is 1 times x to the fourth times negative 3 to the 0? Well, negative 3 to the 0 is 1, and 1 times 1 would be 1, x to the fourth. Negative 3 to the first times 4 is negative 12, x to the third. Negative 3 to the second is 9 times 6 would be 54, x to the second. Negative 3 to the third is negative 27. Negative 27 times 4, doing that in my head here, negative 108x. And the last one, negative 3 to the fourth, is positive 81. And that is x minus 3 times x minus 3 times x minus 3 times x minus 3. So instead of foiling and foiling and foiling and foiling, I can use Pascal's triangle to get the answer. All right, your last one here. I have 2y plus 4 raised to the third. So now, I will give you Pascal's triangle, by the way. That is the row that I'm looking for. So now, writing this down, 1 plus 3, another plus 3, and a plus 1. Take the first term and go in descending order, meaning 2y to the third, 2y to the second, 2y to the first, and 2y to the 0. Then take the second one and do it in ascending order. So 4 to the 0, 4 to the first, 4 to the second, and 4 to the third. All right, so now answer time. I want to do each one of these. 1 times 1 times 2 to the third is 8y to the third. Don't forget to cube both of those in the parentheses. So now 4 times 2 to the second, which is 4, times 3 is 48 y squared. So again, you got a little bit of, you got to make sure to do that to the first power, do that to the second power. So 16 is 4 squared, times 6 would be 96y. And then the last one, anything to the 0 power is 1. So 1 times 1 times 4 to the third is 64. And that is the same as doing 2y plus 4 times 2y plus 4 times 2y plus 4, and probably a heck of a lot faster. So now, your homework assignment is out of the book on page 170, 3 through 23 odd, 24 to 39 odd, and 43 to 46 all. If you have any questions, please make sure you talk to your teacher, and good luck.